Hi students, welcome back to VSM Math tutorial. In this session, we are going to discuss one of the important numerical techniques which is used to solve the differential equations, that is Milnes Predictor Corrector formulae or Milnes Predictor Corrector method. So first we learn what is the definition or the statement of this Milnes Predictor Corrector method and what are the prerequisites to apply this rule. Then we can solve one or two problems on this Milnes predictor formula. Okay, let me take the statement of this problem. What it says: consider the differential equation y dash, it is also denoted as dy by dx equal to f of x comma y, with a set of four predetermined values of y. There y of x naught equal to y naught, y of x1 equal to y1, y of x2 equal to y2, y of x3 equal to y3. Here this x naught, x1, x2, x3, they are all equally spaced values of x with the h, means this h is called width or length of the interval, means h indicates the difference between or the distance between x0 and x1, x1 and x2, x2 and x3. That distance is nothing but what? H. Means if I wanted to show here, you just see here. So how to denote h? This is, suppose if I take x0, this is x1, this is x2, this is x3, this is x4. For every interval we have this gap or this length. This is nothing but what? H. Okay. This is also called width. Therefore, you remember x0, x1, x2, x3 are equally spaced. Equally spaced means this length or this particular x0, x1 length, if I take, let me take 1 centimeter or 1 unit, then between the x1 and x2 should also 1 unit, x2 and x3 should also 1 unit, x3 and x4 should also 1 unit. Then we can say that it is equally spaced intervals. Otherwise, it is unequal length of intervals. Now, to apply Milnes Predictor Corrector method, we must have the equally spaced values. Okay. Then, when we have this, the Milnes Predictor Corrector formula give an expression to compute the next value. Now you see here x0 is there, x1 is there, x2 is there, x3 is there. Corresponding y0 is there, y1 is there, y2 is there, y3 is there. So after y3 which value will come? y4. y4 should be corresponding to what value of x? Definitely x4. So we have to find y4 at the point x4 and we have to represent like this. So y of x4. Y of x4 is nothing but y of x0 plus 4 times of the length of the interval, that is y4. So to find out this y of x4, we have predictor and corrector formulae. So in that, the first formula is what? Predictor formulae. So what does predictor formula says? y0 plus 4h by 3 into 2y1 dash minus y2 dash plus 2y3 dash. This is called predictor formula. Then y of x4, or this can also be written as y4 of c. C indicates corrector, p indicates predictor. So y2 plus h by 3, y2 dash plus 4y3 dash plus y4 dash. This is corrector formula. So these two formulae are used to find the y of x4 value. Now you see x0, x1, x2, x3 are countable values or limited values. That's why to this limited value we have written this formula for that limited values. We can also generalize this predictor corrector formula for n values. So that is, the formula can also be written in the general form as yn plus 1 of p equal to yn minus 3 plus 4h by 3 to yn minus 2 dash plus minus yn minus 1 dash plus 2 yn dash. Similarly, the corrector formula is yn plus 1c equal to yn minus 1 plus h by 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. These two formula or the generalized formula for Milnes Predictor Corrector methods. Okay. Now this is all about the theoretical part of the Milnes Predictor Corrector formula or method. Now we can take one problem and we will learn how to solve this Milnes Predictor Corrector method. And I said in the beginning, what are the prerequisites? Prerequisites are these. Means we must have a set of 4 predetermined values. For most of the engineering topics, the values are restricted for y4 or up to x3 they will be given, and we have to find out y4 at the point x4. That is the reason here I have taken standard problem. So I am finding y of x4. Okay. So let me take one simple problem on this. This is very important, dear students. Now let me take this example. So if dy by dx equal to 2 times e power x minus y, with the conditions y of 0 equal to 2, y of 0.1 equal to 2.010, y of 0.2 equal to 2.040, and y of 0.3 equal to 2.090. So using these 4 conditions, we have to find out the next value of y of 0.4. We have to find y of 0.4. Also they have given in the question one more important point. We have to correct the answer for 4 decimal places by using Milnes Predictor Corrector method. Okay. So you see, before going for the solution, in the previous sheet if I say to operate Milnes Predictor Corrector method, what are the things are required? The derivative of y1, derivative of y2, derivative of y3 are very important. Means y1 dash, y2 dash, y3 dash. But in the problem, you see only the y0, y1, y2, y3 are given. y4 is not given, and also y0 dash, y1 dash, y2 dash, y3 dash are not given. We have to find them first. So it is very simple. So first thing, you have to write the x values. X values are these are 0, 0.1, 0.2, 0.3. So that is x0. x0 equal to what? 0.1. Sorry, 0. First value is 0. Then x1. x1 is what? 0.1. This value. And x2. x2 is what? 0.2. Then x3. x3 is what? 0.3. Then we have to find out x4. x4 also they have given 0.4. Then the corresponding function values, y value they are given. So that is 2. So if I define y at x0, that will be what? y0. y0 will be what? 2. Then y1 will be 2.010. Then y2 will be what? 2.040. Then y3 will be what? See, these are the values. This is y0, y1, y2 and y3. 2.090. Then y4 we have to find out using Milnes Predictor Corrector method. Now this is very important. Y dash equal to 2 into e power x minus y. How to find out? If I define this y dash at the point x0 and y0, then I'll get what? y0 dash. See, for one value I'll write in detail. You have to follow the remaining values in the same way. If I define this y dash at the point x0, y0, I'll get y0 dash. How to define? Define means what? I have to replace x by x0, y by y0 in y dash. Means it becomes what? 2 e power x0 minus y0. So this x0, y0 value I have here. If I replace 2 into e power x0, x0 value is what? 0 minus y0, y0 value is what? 2. So what is the answer? E power 0 means 1. So 1 into 2, 2, 2 minus 2, 0. Therefore our y0 dash value is what? 0. In the same way, we have to find out y1 dash. y1 dash means what? 2 into e power x1 minus y1. So x1 we have, y1 we have to replace them. So it becomes what? 2 into e power 0.1 minus y1. y1 is what? 2.010. So if I simplify this value, so how much I'm getting? I'm getting 0.2003. Okay, this is the very important process to find out all the derivatives. Okay, now y2 dash means I have to define this y dash at the point x2 and y2, means e power 2 into x2 minus y2. So 2 into e power x2 value is what? 0.2 minus y2 value is what? 2.040. So if I solve this using calculator, I am getting the answer as 0.04028. Similarly, y3 dash equal to 2 into e power x3 minus y3, that is 2 into e power x3 is how much? 0.3, corresponding y3 is how much? 2.090. So answer, if I solve this using calculator, y3 dash will be 0.6097. So now we have y1 dash value as 0.2003, y2 dash as 0.4028 and y3 dash as 0.6097. These values only are written separately. And this last decimal may vary based on the calculator configuration. If you are using scientific calculators, based on the calculator configuration, this last decimal value may vary, but rest all, this 0.2, 0.4, 0.6 is same in all the calculators. And since it is a numerical technique, that minimal decimal variation can be accepted. Okay, now once if we got all these values, first we have to write what? Milnes predictor formula. Okay, first we have to find out Milnes predicted value. So Milnes predictor formula. So what is the Milnes predictor formula we have learnt? That is y4 of p, that is predicted value, equal to y0 plus 4h by 3 into 2 y1 dash minus y2 dash plus 2 y3 dash. This is the predictor formula. So we have all the values here. Just we have to replace all these values in the predictor formula. So y4p, that is equal to y0. y0 here we have 2. So 2 will be replaced plus 4 times h. h, as I said, length of the interval of x 0, 0.1, 0.2, 0.3, 0.4. So h value will becomes what? 0.1. Because the difference if I take, it is 0.1. And since it is equally spaced for every interval, x, that h is same. Divided by 3 into 2 times y1 dash. So where is y1 dash? Here, 0.2003. 0.2003 minus y2 dash. y2 dash is 0.4028. 0.4028 plus 2 y3 dash. y3 dash is what? 0.6097. So if we solve this using calculator, then we will have predictor value or predicted answer, that is 2.1623. 2.1623. Okay, this is very important. Everybody should remember this predicted value itself answer to this differential equation, the given question. Since we want better approximate answer, we have to proceed for the corrector value. Now you see the formula in the corrector formula. So this is our corrector value. y2 plus h by 3, y2 dash plus 4y3 dash plus y4 dash will be there. This y4 dash we have to find out. How to find out? Using this predicted value. So how to find out y4 dash? So y4 dash equal to, so means here we have the definition or the given function. This is y dash. Y dash value is what? 2 e power x minus y. So y4 dash means I have to replace x by x4, y by y4. That is our y4 dash, right? So 2 into e power x4 minus y4. This y4 we don't know. So what is the recent y4 we got? This predicted value. That we have to write. Predicted value. So 2 into e power x4. What is the x4? 0.4. 0.4 minus the predicted value. The predicted value is 2.1623. 2.1623. So if I simplify this, what is the answer I am getting? 0.8213. This is our y4 dash. So y4 dash equal to 0.8213. Please highlight your answer in boxes always, so that the evaluation process is easy. Okay. Now, once we got this y4 dash, we have to use the corrector formula. So Milnes corrector formula is y4c equal to y2 plus h by 3 into y2 dash plus 4y3 dash plus y4 dash. This is equal to, or you can write in that down. So y4c equal to y2. y2 here 0.2040. 0.2040 plus h by 3. H value is 0.1. So 0.1 by 3. y2 dash is here 0.4028. 0.4028 plus 4 into y3 dash is also 0.6097. 0.6097 plus y4 dash we have here. Recently we got it, that we have tried. 0.8213. So if we simplify, we have to get corrected value. So using calculator, if you simplify this, we will have the corrected value. So that corrected value is what? 2.1621. This is our corrector formula. Now you see, in the question they have mentioned, we have to find out y of 0.4 and we have to correct it to for 4 decimal places. What is the meaning? That we have to compare the predicted value and corrected value 4 decimal places. Now you see, these are the 4 decimal places. So here 1623, here it is 1621, means the last decimal, 4th decimal is different here. Here it is 3, here it is 1. But in the question they are asking, we have to correct it to for 4 decimal places. Since the 4th decimal is different here, we have to repeat the process, means we have to operate corrector formula one more time. So we cannot write again corrector formula as it is. So in the corrector formula y4 dash is there, no. In the using predicted value, how we got this y4 dash? The same way, using this corrected value, we have to find out that the y4 dash one more time. Then only we can operate Milnes corrector formula twice or one more time. So therefore, y4 dash we have to find out one more time. That is 2 into e power x minus y4, or y is there. So this we are defining at 4th point, that is y4. So it becomes 2 into e power x4. So y4 c corrected value, the recent corrected value or the recent y4 value is this. Earlier the recent y4 value is this, therefore that is used in y4 dash. Now in the second time y4 dash, the recent value of y4 is this. So this we have to use. 2 into e power x4 is how much? 0.4. So minus this corrector value 2.1621. So if we simplify this, then we will have y4 dash. y4 dash as how much? 0.8215. 0.8215. Now you see this. Earlier the y4 dash is 0.8213, it is 0.81. Means only 4th decimal, very slight deviation. Therefore, we have to operate corrector formula one more time. So, apply corrector formula again. Means in the question also they have mentioned we have to use corrector formula twice or till the fourth decimal consistency. So here the first two decimals are not same. So that's why we are proceeding for the next iteration. So y4 same. In the same formula we have to replace all the values. So y4c equal to, what is the formula? Y2. So in the only this y4 dash is different. The rest all values are same in the previous corrector formula. Only this y4 dash we got it as new y4 dash value. Okay. Therefore, the rest all values we have to keep it as it is. So y2 0.2040 plus 0.1 by 3, then 0.4028 plus 4 into 0.6097 plus, instead of this 0.8213 we have to write this, that is 0.8215. 0.8215. This value we have to replace. So after this we will have corrector formula. The second time the answer is what we will get, 2.1621. 2.1621. And you see now this is the corrected value, this is the second corrected value. You check the 4 decimal values, 1621, 2.1621. All the 4 decimals are same. Therefore, this is corrected for the 4 decimal accuracy. Once if both are same, we can say that there is a consistency in the solution. When there is a consistency in the solution, we can conclude that the solution of this differential equation are the y of 0.4 value. So what is that? 2.1621. This is the y of 0.4 value. Here what you have to remember, dear students, as I said in the beginning, this predicted value itself answer to the question, that is 2.1623. Since we need better approximate answer, we are going for corrector formula. Therefore, only the decimal change will be there in the corrector answer. Okay, it is 2.1623 means it is 2.1621 means it is also starting from 2. So why I am telling, sometimes in a hurry-burry way you may commit any mistakes in the calculation part. In that case you have to relook or you have to cross-check your answers. Here I am getting 2.16. Here if I get some 8 point or 4 point or 6 point something, then this answer is wrong. Because as I said, this itself answer, since we need better approximate answer, only the decimal changes will be there when we do more number of iterations, but the main answer will not change. Okay, so whenever if you have a very big deviation, or here too if you are getting 3 or 4 or 5 or something, then you will get to know that somewhere in the calculation part you have done the mistake, so you have to relook into the problem. Okay, so this is how the whole process taken care to solve the differential equation with the condition using Milnes Predictor Corrector method. Okay, so hope you all enjoyed this session. Thanks for watching. If anybody is not subscribed at my channel, kindly subscribe and support, because I am trying to help you all in the maximum way. See, whenever I am getting time, I may not get complete free time. Whenever I am getting time, I am using Blackboard, I am using Sheets, I am using PPT. So it is only to help our student community. Okay, so thanks for your support till date. Those who are new to my channel, kindly subscribe and support me. Thanks for watching. We'll meet in the next video. Thank you all.